Hello everybody, let's keep learning as domain analysis module of continuous system. Hello everyone, next we will learn 4.4 below, the main nature of the Laplace transformation. First, let's look at the linear nature. This property is similar to the linear properties of the Fourier transformation. If the Laplace transformation of f1t is f1s, the Laplace transformation of f2t is transformed to f2s. If k1, k2 is constant, k1 multiply f1t plus k2 multiply f2t. The Laplace transformation is equal to k1 plus f1s plus k2 multiply f2s. Let's look at an example question. Solve ft equals cosine omega t, image function of epsilon t. According to the Euler formula, ft equal to the second side of the half bracket e to the power of j omega t plus e to the power of j omega t. And then you can get it based on linear characteristics. Laplace transformation of cosine omega t shown in the formula. Similarly, the Laplace transformation of sine omega t is as shown in the formula. Let's look at the differential properties of the original function. If ft Laplace transforms to fs, the Laplace spots of the derivative of ft are transformed to s multiplied by fs minus f0 negative. The Laplace transformation of ft second derivative equal to s squared fs minus s multiplied f0 negative. The value of the first derivative minus ft at t equals 0 point. Laplace transformation of the n-order derivative of ft inside fs equal to s. Subtracting sigma m equals 0 to n minus 1. As n minus 1 minus m subside multiplied by f0 negative m step derivative. If ft is a causal function, then the value of ft and its step derivatives at 0 negative points is 0. This differential feature has a more concise form. The unordered derivative of ft is equal to the inside of s multiplied by fs. The most common forms are ft first order derivative equals fs of s. Second derivative of ft equal to s squared distributed by fs. For example, f1t is known to the derivative of the negative 2t subside of e. Seek f1t unilateral Laplace transformation. Because f1t is a causal function, so the Laplace transformation with the derivative of ft equal to s times s. And f1t Laplace transformation. Laplace transform to the Laplace transformation of s multiplied by e minus 2t second side. And the e minus 2t side of Laplace transforms to 1 compared to the previous s plus 2. So the Laplace of f1t is transformed into s over s plus 2. Let's look at the nature of the delay. If ft Laplace transforms to fs, ft minus t0, epsilon t minus t0 Laplace transform is the negative st0 times square of fs on e. This property can also be referred to as the time domain of transformation nature. For example, now ft is equal to t times of the epsilon t minus 1. Solve fs. T multiplier epsilon t minus 1 can be written as t minus 1 multiplier epsilon t minus 1 plus epsilon t minus 1. In this way, fs is equal to t minus 1 times the size of the epsilon t minus 1. Laplace transform with epsilon t minus 1 depending on the linear nature, is equivalent t minus 1. Laplace transforms support epsilon t minus 1 plus the Laplace transformation of epsilon t minus 1 and t minus t0 multiplied by the epsilon t minus t0. Laplace transformation equals a negative st0 square of fse. The Laplace transformation of epsilon t is 1 over s. The Laplace of t transforms into 1 square of the s, so that you can get t minus t1 multiplied. The Laplace epsilon t minus t1 transforms to the negative s subside of one of the squares of s. The Laplace epsilon t minus 1 transformation is changed to negative s side of 1 of se. So fs of the Laplace transformation is 1 of the squares of parentheses plus 1 of the s brackets. Multiply e's negative s. Let's take a look at the scale shift. If ft Laplace transforms to fs, then f(a)t Laplace transformation is 1 over a times Laplace transforms in a s over a. If you combine time shift and a scale transformation, there is f(a)t minus b epsilon at minus b Laplace transform equal to 1 in af. S then a multiplied by e negative as a point b. Here is a case in point. If ft Laplace transforms equal to 1/10 of the square of s, elephant function of f 2t minus 5, the problem is to combine time shift and scale transformation. According to the above formula a to b is 5, substitute in the above formula can be obtained. f2t minus 5 is minus 5/5 of the s side. Here's a look at Laplace transformation of the original function integrals. If ft of the Laplace transformation is fs, then the Laplace conversion of ft points equal to s in fs plus s in f. Integral value at 0 negative point. Second order integral ft is equal to second order integral s squared. fs plus ft fs squared, the integral value of the point at 0 negative point, plus second order points of s point f at 0 negative point. Similarly, Laplace transformation of ft in level integral can be obtained. Its Laplace transformation is 1 fs of n squares of s. Add that sigma m is equal to 1 to m. Sn minus m plus 1 the square ft. The m level integral at 0 negative point. If f is at 0 negative point, m order integral is 0, so you can get ft. Laplace in the n-level integral sets transformed into 1 fs of n squares of s. Let's solve for the causal signal shown in figure A below. ft unilateral Laplace transformation. According to what we said in part 2 from figure A, you can see that the graphic is made by the center in the t equals 1. Two triangular functions of n t equals 2 are superimposed. Its function value can be written as ft equal to rt minus 2 times rt minus 1. Add 2 times the rt minus 2 brackets plus 2x bracket minus 1 minus 2x rt minus 2. Add rt minus 3 brackets. Derivative of ft can be obtained. The value of ft derivative its value equal to 2 times the bracket epsilon t. Subtract epsilon t minus 1. Subtract 2 times the bracket epsilon t minus 2. Subtract 2 times the amount of epsilon t minus 3. The formula is consistent with the results shown in figure B. The value of ft is obtained by conducting it. Its value is Subtract 2 times the size of the epsilon t minus 1. Subtract 2 times epsilon t minus 2 plus 2x of the epsilon t minus 3. The formula is consistent with figure C. It's a combination of punch functions. The nature of the Laplace transformation according to the amount of rad epsilon t. And the linear properties can be ft of the Laplace transformation. Fs equals 2 minus 2 times the negative s subside of e. Subtract 2 times e minus 2s subside plus 2 times e minus 3s side. Laplace transformation, if it can get a second order point, you can get the Laplace transformation of the original function ft. And the ft integral value is the step function. The value of negative t at the zero negative point is 0. ft second order integral sits as a continuous function. The value of negative t at the zero negative point is also 0. So fs is equivalent to s is multiplied by f2s equal to 2 parts of the square of s multiplied by upper bracket 1 minus the negative s subsquare of e. Subtract e minus 2s subside plus e negative 3s subside. Here's a look at the pen nature of estimates. If ft Laplace transforms to fs, the Laplace transformation of ft multiplied by e to the power of negative alpha t by e to the power of negative alpha t equal to fs plus alpha. The same way, we can get ft multiplied by the e to the power of alpha t. The value of the Laplace transformation is fs minus alpha. Convergence domain is, let's look at the e to the power of negative alpha t. Laplace transformation of cosine omega 0 t. According to the cosine omega 0 t epsilon t, the Laplace transformation value is equal to s then the square of the square plus the square of the s plus omega 0 square. So we can get cosine omega 0 t epsilon t Laplace transformation equal to s plus 2s plus alpha square plus the square of omega 0. The same point can get e to the power of negative alpha t. Laplace transformation of sine omega 0 t epsilon t equal to the square of s plus alpha plus omega 0 squares, sin of omega 0. Let's look at the initial value theorem. The initial value theorem is if ft and ft can be Laplace transformation, and the Laplace of ft is transformed to fs, then the value of f0 plus is equal to s multiplied by fs, limits when s tends to infinity. If fs is not true split, we should have diffused it into a true split. Make f1s equal to fs minus k. At this point, f0 plus is equal to s multiply fs minus ks. Limits when s tends to infinity. f0 plus equals s as fs minus f0 plus. Limits when s tends to infinity. Let's look at an example question. Now, fs is equal to 1 over s. Seeking the value of f0 plus. The value of f0 plus equal to ft tending to 0 positive point. That is equal to s multiplied by fs. When s tends to infinity, limit value, because the value of fs is equal to 1 of s. So f0 plus is equal to 1. We know that if fs is equal to 1 over s, then ft is the step function epsilon t. Epsilon t equals 1 when t is greater than 0. This also shows that ft has a value of 1 at the zero positive point. Here is a look fs equals to 2s to s plus 1. Find the value of f0 plus. Because fs is not a true split, so now I'm going to turn it into a true split. The value of the true split is 2 minus 2 compared to the s plus 1. Subtract ks according to f0 plus equals s by fs, the limit of s tending to infinity. We are replacing the value of fs with you can get f0 plus. After the operation, f0 plus equals negative 2, so the positive value of the f0 is minus 2. Let's take another look at the convolution theorem. The convolution theorem is that if f1t, the Laplace transformed into f1s, the Laplace of f2t is transformed to fs. f1, f2t are all starting functions. Laplace transformation of f1 and f2t convolution is f1s on f2s. Laplace transformation of f1t and f2t product equal to 1 over 2 pi j. f1s on row f2s. Convergence domains are the common parts of f1s and f2s. It's a convolution theorem. Look at the differential theorem of s. If the Laplace of ft is transformed to fs, then the inside of t is multiplied by the Laplace transformation of ft. N-order derivative equal to -1 inside fs. The most common form is t minus x ft Laplace transform first derivative equal to -fs. We know that the Laplace of the epsilon t transforms into 1 over s. Then t double epsilon t Laplace transformation is the derivative of 1 of the negative s, equal to 1 square of s. Then the Laplace transformation of t is s squared t. We can write the square of t by the square of the epsilon t. T multiplied epsilon t equal to t times, so the value of its Laplace transformation is -1 over s squared derivative, 3 sides equal to 1 over s. That's the differential nature. The same way, we can get t's n sub square epsilon t. The Laplace transformation is the order of n plus 1 square of s. That's all, thank you. Class is over, thank you for listening.